Hello friends, welcome to this channel. This is G Solutions, where we find solutions for your needs. Today, let me show to you some concepts regarding the currents in functions of time. Actually is the case of vanishing current. Now, to show to you this concept, let me just give a value for three currents for I sub 1. Okay, I sub 1, I'll put 6 plus J10. Okay, and let us transform this rectangular form to polar form. So will give us 11.66 cis of 59.04 degree. And for another currents, let's say I sub 2. Okay, I sub 2 is, I'll assign 8 minus J4, which is also has a polar form of 8.94, cis of negative 26.57 degree. And another current is I sub 3, which is negative 14 minus J6. Okay, and that will be 15.23, cis of negative 156.80 degree. So these are the current's value. This is in ampere. So to let you know that, suppose these are the currents in the branches which are connected to N node. So here is an illustration. For instance, this is a branch, another branch here, and another branch here. So this is node N. And suppose I let this be my I sub 1 and going through N, and another current here, I sub 2, and another current here, which is I sub 3. So let us be reminded that we have a law for analysis which was developed by Kirchhoff's. We call this as the Kirchhoff's current law. What is this? It tells us that Kirchhoff's current law says that all the currents that goes through a node should be marked as positive, and the current that is going out or going away from the node is negative. And when you sum up those currents, it should be equal to 0. So KCL will be our basis if this value that I assign here as I1, I2, and I3 are correct. Are these values correct? So if you add all of these things, all of these current values, and you give a result of 0, then our currents are correct. So these are the conditions that we should take consideration to be able for us to know if the values of the currents are correct. Okay, so just to show to you, let's have since we are dealing with the time function here, considering the time or in t. So let us get the values for I sub 1, I sub 2, I sub 3, wherein the time is equal to 0 seconds. Okay, so now we will consider I sub 1 here as our reference phasor, and let us compute now for the currents at 0 time. So for I sub 1, since we have here 11.66, this is an RMS value, so we make that as a maximum value. To be able to have the maximum value, 11.66 should be multiplied to square root of 2. This now become a maximum value. So we get now the form sine, okay, omega t plus 59, the angle 59.04. But since this is 0, so we have only 11.66 times square root of 2 sine 59.04. Now if you are going to get your calculator, so okay, hope you see my calculator. So you have here 11, okay, 0.66, okay, times square root of 2 times sine 59.04, okay, equals, that will be 14.14. So the I1 is 14.14 ampere. Okay, now for I sub 2, same thing. What we have done in I sub 1, we do also to our current I sub 2, which is this one. So you have here 8.94 and you convert this to maximum value, so multiply it by square root of 2. Again, sine omega t is already 0, so we just take the angle, which is negative 26.27 degree. Now if you have your calculator, it will give us negative 5.66 ampere. For I sub 3, same thing, that will be 15.23 multiplied to square root of 2. Again, sine, okay, negative 156.80 degrees, since that our t is 0. So by calculator, okay, you get 8.48 ampere. Now we are going to add this current, so I sub 1 plus I sub 2 plus I sub 3 equals 0, because all of the direction of these currents are going through the node. So we are going to add, so you just add 14.14 plus negative 5.66, okay, so you see that, okay, and then plus negative 8.48, okay, okay, so then you press the equal sign, it will give you 0. So it means that at 0 seconds our currents give us 0 sum or summation of our currents is 0, which means that the values assigned to I1, I2, and I3 are correct. Okay, now how about if the current are at a certain degree? It means that our time is not on 0 seconds but in some other time. For instance, let us add 40 degree, okay, so I sub 1, okay, again is 11.66. So I am just showing to you that these values are RMS, and I change it to a maximum value, and using this general form, sine omega t plus the theta or the angle, but I am using the 59.04, and let me just add here a value, for instance 40 degree, okay. This 40 degree can be at a certain seconds. Okay, so because at t where t is equal to 0 seconds, this one is 0, but at a certain value of your time, we can have a 40-degree addition here. Okay, so now if you are going to solve this one, it will give us 16.28. You use your calculator. Okay, ampere. Now for I sub 2, again same thing, you have 8.94 times square root of 2 sine, okay, I'll copy negative 26.57, and again I add value of 40 degree. This is a value, a degree in a certain time, not at 0 seconds again. So again, if you have your calculator, you can have a value of 2.94 ampere. And for I sub 3, again 15.23 square root of 2, so sine, okay, and again 156.80 degree plus 40 degree. Press your calculator and it will give you negative 19.22 ampere. Again, if you are going to solve the summation of these currents at a certain time, not at 0 seconds, in which it gives us 40 degree, we add these currents, 16.28 plus 2.94 minus 19.22, and it will give us 0. Again, we have proven to you that at any time, if your currents have a value which is equal to 0, at any time it will be always 0. So these are some concepts that you must know in solving currents involving the functions of time. So thank you for watching this video, and let us go further by giving you some examples to the next videos. Thank you so much for watching.